It was just some quick introductions just before we started, just some formalities. Yeah, I just want to say sorry for this ran over so quickly. Um, our session chair today will be Bao Verde. Yeah, he's the Professor Bao Verde is the director of the Center for Communications Technology Research Group. His research is in the area of the microwave wireless communication, encompassing 5G mobile phones to satellite technology. Professor Bao Verde graduated with an English honors in communication engineering and a master's from Leeds University in the UK. He obtained his PhD from the University of North London in the UK, and he has worked as an academic at the Open University and Leeds University. Prior to this, he was a research and development electronic engineer in the Future Products Department at the Teledyne Defence and at PYE TVT in Cambridge. Yeah, so everyone welcome Professor Bao Verde. Thank you. And
thank you so much for the introduction.
It's all right. And then we can just go on straight onto the first.
Yes, please.
Paper.
Bernard
Sorry
Hayden,
about
please
that.
go ahead with your paper. The paper is entitled Lambda Computex LC towards a computational enhanced understanding of production and management. You have 15 minutes, 12 minutes for presentation, 3 minutes for questions.
So thank you for your kind introduction. I hope you hear me all and you see all the presentation. And so with me is also my student Volodymyr Alexiev, and he maybe will also say something concerning the presentation. And so the title is Lambda Computatrix towards a computational enhanced understanding of production management. And so first I give a content overview, so the introduction, what is the Lambda Computatrix, and some applications in the field of simulation and production and management methods in the artificial intelligence ledger model, a management model, and the production and logistic model. And then finally, I give some summary, conclusion, and outlook. And so first to the knowledge relation. So we have first the humans, also with relation to management, that when you think of Otto Scharmer from MIT, for example, he describes after a survey of a lot of people that that all the people in the world, and especially the genius people in the world, have some kind of methodology to investigate something. That means they read something, the sensor data, they correlate something, they feel something, and they project something. That leads then also to the prototyping process, and this is also related to the innovative science nowadays. And so this is related to the human side. And on the other side, there's the machine side that is related to artificial intelligence and other fields. And so this is related to first have data, so then to find out some kind of correlation, and then in the end to get to an extrapolation, to a prediction. And so this is also related, and now we have the human and the machine, and they are also interacting, and this is now what I'm talking about. So this the artificial intelligence is used to support human values, but human values are not quite directly implemented. And so this is what theorem proving does. It implements some directly values with the method of logic. And so I explain this more exactly later. So then another thing is production and management, and so this is very related to first of all to a lot of technical things, like for example artificial intelligence is used for image acquisition and also other things. and management, and this is some kind of top. And so they use nowadays systemic analysis, for example. And so the impact is very high on the society and the economy for production management, because also when we relate it to Karl Marx, for example, then the whole society is related to production. And so when we relate also to the automation in production, what is nowadays going on, then this leads to very fast production, but also in a fast, a high impact of what is done in production. And therefore it has to be done quite rightly. So what has to be done, otherwise there's a big chance of failure in the society. And so I will try to answer three questions. And what is the theory improving, especially in the context of production management? And how can the management actively use theory improving in production processes? And why is theory improving increasingly important for future production and management? And so first, the Lambda Computatrix is the title of the paper, and it's based on the Lambda calculus that goes back to Frege's Begriffsschrift, sozusagen, and where he implements some kind of new form of logic. And so when we look at the history of logic, we have roughly three types of logic. The first is the propositional logic. This goes back even to Aristoteles, and also Leibniz has invented it, but he did not publish it. And the first who published it was Boole, and so now this is quite common use in the computer implementation. And so only later on, so the first order logic was implemented in the 60s or so at about, and they also implemented logical languages. And so these logical languages are like Prolog and Isabelle nowadays. And so they also use then higher order logic. And so this higher order logic uses this lambda calculus, and that means they have some quantifiers, and this is all or one. And so this is also related to systems theory, because, for example, you make argumentation with what is the whole system and so on. This goes even back to the ancient Greeks. And this is nowadays also related to explainable AI, called XI. And so there, what we can see, there's a phase transition towards all by means of artificial systems like the improving to by means of the lambda calculus, and this is now implemented in whole programs. And so practical implementations are nowadays in Isabelle or Lambda Prolog are the latest developments. And so now when we look at production management, how could we use it there? So what is important there is that we have modeling simulation, and out of this we get correlations and prediction. And so then, for example, in production management, we have also technical innovation systems, technology, life cycle analysis, and so, and they're related to growth and cybernetic models. And so on the simulation and modeling side, we have, for example, industrial process simulation with Witness, AnyLogic, Aspen Plus, Aspen Batch Plus, Pro 2, and many others. And so we have some kind of simulation of the production. And then what we now need, this is based on the first two types of logic, but we need now the integration and merging with artificial intelligence like the theory improving. And so that means we can use, like with Prolog, for example, the knowledge database in industry. And this has not been done, and also by the computer programmers like Witness, they did not implement the artificial intelligence. On the other side, there, for example, AnyLogic is also using nowadays links to artificial intelligence, deep learning, and so on. And this is quite a new field, and it's very important for the production field to implement this. And so when we use, for example, the theory improving, then we use logical reasoning, and this is therefore so important because people people want to understand it, and the manager maybe manage it on a quite quick decision and a rough understanding. And so, in fact, also from the mathematical point of view, we have some kind of multi-criteria optimization, and we do this by means of the improving techniques then. And so the second application example is artificial intelligence ledger model. And so first, it's according to Bensmüller, we solve hard problems. That's done now. We know how to make prediction and how to even reason abstractly and rationally. But what is not done now, because it's too complicated, to reflect ourselves, what is the relation to the environment and so on, by means of artificial intelligence and the machines, so directly with the humans. And so also to interact socially with other entities. And this can be done with theorem proving by implementing social norms, and those norms are implemented on a whole level. And based on this, you can implement a specified artificial intelligence for persons or companies, and this is then the value of this new kind of implementation. And so this is also well in accordance with Socrates and Leibniz thoughts and primary visions. And so this also increases the human machine interactions by means of a self-control training of persons, in this case the manager, for example, or the lower and other people in industry and society. And so now the third application, maybe Volodymyr, you could say something to this part.
Yes, thank you very much. So, well, also one of the most of the possible areas of application of theorem proving is the management of logistics process. Here is, for example, and we asked a question in this works, for example, what are the tasks and challenges we have in logistics, and how it can be connected to theorem proving, and actually where theorem proving can be useful for logistics applications, for example. And here you can see the most common questions that occur in logistics management and supply chain management. So make to order, for example, or make to stock, push or pull. So push or pull, yes. So inventory logic, when inventory centralization or decentralization, so quite decision process, so global decision process, and make or buy also as another strategic decision. So these all are strategic decisions that occur very often in supply chain management or logistic management. And to make these decisions quite sustainable, quite reasonable, we have to get an understanding that our supply chain, for example, is really reliable. And referring to the work of Wacker, for example, so theorem proving approach can be used to check the reliability of the supply chain, and actually using the reliability block diagrams, which are used to conduct the reliability analysis of logic on logistics service supply chains. So using the reliability block diagram as a high order logic.
Oh, thank you, Volodymyr. So now I come to the conclusions and outlooks. So now the future production of and societies is increasingly connected. It means we have exponential consequences because of the back coupling. And so this is, for example, the lockdown phenomenon is very important. One single negative consequence shuts down a whole production chain. And therefore we have to be more rational. The production has to be extremely highly rational. Another solution to this may be also decentralization. What is the outlook? The outlook is that we have to improve human support by theorem proving using the lambda computatrix, and the interactivity by a self-control training with the higher order logical reasoning. And we have to develop learning tools to decide increasingly rational in the society, especially in industry and management, and to justify decisions quickly and correctly. Uh, and last but not least, we have to make the distinction of wide and narrow interpretation, because this is now then a new emerging field of the terrain proving. And we have that for the last thing also a seamless integration for managers and all humans to get to the goal of a good society. Thank you very much.
Thank you.
Thank you so much, both speakers. Does anybody have any questions? Looks like there's no questions. Everybody found this, well, I've certainly found your presentation very interesting. So thank you so much for both speakers.
Thank you also for
Thank you also.
Okay, the next talk is by Ajay Gautama Padrada. The title of the presentation is Comparative Analysis of Grid and Tree Topology in Agriculture, WSN, with PRL Routing. Is Ajay Prodada here?
Yes, hello, Mr. Bal.
Please go ahead. You have 15 minutes altogether.
Okay, thank you. Let me introduce myself. My name is Aji Gautama Putrada. I will directly share my screen. I've prepared the video for our conference. I'll play the video. Hello, everybody. Sorry. Let me introduce myself. My name is Aji Gautama Putrada.
Please go ahead.
Okay, thank you. And I will be presenting to you my research called Comparative Analysis of Grid and Tree Topology in Agricultural WSN with RPL routing. Let's start my presentation. So firstly, this is the introduction. First, RPL is a proactive tree-based routing protocol used on 6-low-PAN networks. 6-low-PAN is usually a network that uses IPv6. In previous studies, there are many researches in terms of comparing topologies in the performance of wireless sensor networks, or WSN. For example, a comparison of grid and random topology, and there's also a comparison of chain, linear circle, random top, and random center topology. And there's also a comparison of random, manual, linear, and elliptical topology. And there's also a comparison of star, mesh, and tree topology. There are many implementations of WSN. One of them is agriculture. Each implementation has their own characteristics. And here, Contiki OS is a kind of RTOS, or real-time operating systems, that can be embedded inside the WSN, and QJA is one type of simulator to simulate Contiki OS. So our research aim is to compare the grid topology and tree topology using QJA simulator with a case study of agricultural land to get the results in the form of power, routing metric, ETX, throughput, and delay of each topology, and analyze which topologies are better applied for the WSN. So these are some terms that we are using. WSN is wireless sensor network, which is a kind of computer networks that is usually used for computers, but in WSN is used for microcontrollers that control the sensors that are usually related to IoT, or Internet of Things. And routing is the path finding in a network. Usually when we use mesh network, we need to find a better path to reach the destination of our package. And grid topology is a topology that forms the grid shape. So usually it forms a tree shape in tree topology or in star topology, where one node will connect to many other nodes in tree. The lower the node, the more the branches. So next discussion is the simulation design flow. Here, first we initiate sender and sync a node, and then a connection will establish between the sender and the syncing node, and there will be a transmission, and there will be a receiving of the packet data. And then we will receive the power, the routing metric, the ETX information from the collect view, and then there will be a PCAP, which is derived from Wireshark, which is an application to measure the performance of the networks. And then we analyze the simulation results of all metrics. That is the end of the design flow. So here I want to show you that there are 6 different topologies made. Why there are 6 different topologies? Because there are 3 different scales. So we want to see the scalability of our system. The topest is the smallest scale, and the low one is the largest scale. And then each scale there are 2 different topologies. The left one are the grid topology, and the right one is the tree topology. There are 2 times 3 different topologies. There are 6 topologies. The top one consists of 20 nodes, and then the middle one consists of 30 nodes. Each left and right have the same amount of nodes, just different topology. And the bottom one, there are 42 nodes in each of the topology. So secondly, we will discuss the simulation parameters. First, the wireless channel model is the UDGM distance loss, and the radio duty cycle is 23 MAC, and the MAC is IEEE 802.15.4, which is ZigBee. And then the routing protocol that we use is RPL, and the transport protocol that we use is UDP, and the topology, like we said in the title, is grid and tree. And like before, I said that there are 3 different nodes, 20, 30, and 42, and the area size is 100 meters times 100 meters, which is we assume the size of the agricultural land that we want to implement. And then in each simulation, we run for 15 minutes, and the mode type is sky mode, and the transmission range is 50 meters, and the TX RX ratio is 100%. So now we want to discuss about the performance metrics. Like I said before, the tested performance are power consumption, routing metrics, and ETX, throughput, and delay. Routing metric is a value to determine the quality of a transmission route. The ETX value is the expected value of a packet that arrives at its destination without an error. How we discuss about routing metrics and ETX, the smaller the value of the routing metric and ETX, the better the results. This is the first 3 results of our the metrics that we measure: the average power, the ETX, and the routing metric. Here are for each of the 3 different scales: the 20 note, the 30 note, and 42 note. Here we see that when the amount of nodes increase, all of the values increase also. And here we can see that blue, which is grid, is always lower than orange, which is tree. In average power, we know that the lower the power is the better. It means that it is low power consumption, which is efficient. And In ETX, we said that the lower the value of the ETX means the better, means that there is a low possibility of error. And in routing metric also, the lower value of routing metric means that the routing is better in the lower value, which is here is great in each value. And these are the rest of the results, which is the delay and the throughput, which is collected through Wireshark of our simulation. Here we can see also the average delay will increase in the increase of the amount of nodes. And again, we see the delay of the tree is bigger than the delay of the grid. Here we can see in the 42 node, the increase of the tree topology is greater, which is a possible which is a possible exponential growth of tree topology. And in throughput, we can see that when the nodes increase, the throughput will decrease. Throughput means roughly means speed, meaning that the speed will decrease when there are more nodes in the network. And we can see, but in each scenario, the grid is always higher than the tree. So this is the conclusion. Here we will conclude the results of our finding. The first point is a simulation of agricultural WSN with RPL routing and grid topology and tree topology has been successfully implemented with QGIS simulator. The grid topology is superior to the tree topology in all aspects of parameters that we measured, which is the power consumption, the routing metrics, the ETX, the throughput, and the delay. And lastly, we conclude that the choice between grid and tree topology can affect the performance of the RPL routing protocol and is recommended for agricultural WSN. And of
Correct.
which, if we want to build a WSN for agricultural, for example, for agricultural precision agriculture, we can use grid topology rather than tree topology.
Right. Thank you so much, Aji. The floor is open for questions. Anyone with any questions? Okay, there's no questions. Thank you so much, Aji. It was a very interesting talk. Thank you. The next speaker is Aji Gautama Putrada again.
Yeah.
The talk, the presentation, the title of the presentation is designing a monitoring and prediction system of water quality pollution using artificial neural networks for freshwater fish cultivation in reservoirs. Please go ahead.
Okay, thank you for your time. Once again, I want to give my presentation of my research. This is the video. Please let me introduce myself. My name is Aji Gautama Putrada. I will be presenting my research with the title Designing a Monitoring and Prediction System of Water Quality Pollution Using Artificial Neural Networks for Freshwater Fish Cultivation in Reservoirs. At the start of the presentation. First is the introduction. Reservoir water quality must be maintained in accordance with its standards. In predicting pollution in water, an IoT system can be built, which is the Internet of Things, and we can use artificial neural networks to predict the results of the IoT system. Artificial neural network is an information processing paradigm that is inspired by the work system of biological nerves. The IoT is a rapidly growing concept that can be used in many fields. One of them is in fish cultivation. By the introduction that I mentioned earlier, our research aim is to implement an artificial neural network on IoT systems for predicting water pollution in a web-based reservoir and evaluate the performance of the method that we have implemented. So to build our artificial neural networks, it is important for us to be aware of the water quality parameters. Here we use three parameters. The first is the acidity, or we can call the potential hydrogen, or usually the unit is pH, and turbidity. The unit of turbidity is NTU, and temperature, we know that temperature is degrees Celsius. Turbidity means the when turbidity is high, we cannot see through the water, and when it is low, the water is clear. And for each scale, we divide it into bad and good, and also bad. So good is usually in the middle, except for turbidity, which the higher the value, the it becomes bad. So before we go to the ANN, first I want to explain the IoT system that we built. We divide it into three parts: the hardware system, and then the IoT platform, and then we have the application. In the hardware, we build it with an Arduino Uno, which is connected to three sensors, which we have discussed earlier, is the pH sensor, the temperature sensor, and the turbidity sensor. The sensors data collected to the Arduino is sent to the node MCU, which has a Wi-Fi module that can communicate with the IoT platform. In the IoT platform, we use ThingSpeak. In the ThingSpeak, we can see the data that flows inside the IoT platform, and then we can send the data from the IoT platform to our application. Here we use IFTTT, which stands for if this then that. This is a push notification to show the results of the ANN. For example, here now quality pH water is not in good conditions. So secondly, we will discuss about the workflow of our system. Firstly, the system senses the water quality metrics, and then the metrics are sent to a MQTT broker, and then our client will collect the data from the MQTT broker, and then the neural network will predict the water quality. First, the metrics are sent, and also the prediction results are also sent to the ThingSpeak, and then the ThingSpeak will send it to the user app through the IFTT. This is an example. The prediction results are poor. So in creating the artificial neural network, which is a type of machine learning, in building the model we went through four steps. The four steps is to do analysis in the forms of first our is the epoch, which is the learning iteration, and then the learning rate will provide a delta in the each learning steps, and then the momentum plays with the variables inside the neural network, and lastly the training data percentage, which is when we divide the data into training data and testing data. As we explained before, the first step is to test the epoch. Here we have five different values of epoch: 200, 400, 600, 800, and 1000. The largest accuracy comes from the epoch of 600. So here we use the epoch value of 600. The second step is to test the learning rate. Here we have 5 different learning rates: 0 0.1, 0 0.2, 0 0.4, 0 0.7, and 1.0. Here we can see the largest accuracy comes from the smallest learning rate, which is 0 0.1. So here we use 0 0.1 as our learning rate. The third The third test that we use is to test the momentum. Here we have 5 different momentum values: 0 0.1, 0 0.2, 0 0.4, 0 0.7, and 1. The largest accuracy comes from the momentum of 0 0.1. So we use 0 0.1 as our momentum. Then the next one is the training data percentage, which is the composition of the training data and the testing data. Here we have 5 different percentage values. The first is 10%, the second is 30%, the third is 50, the fourth is 70, and the last one is 85%. Here we can see the largest accuracy comes with from 85% of training data percentage. So we use 85% as the training data percentage. So we have assumed we have got the most optimum model of our artificial neural network, and then we implemented that model into our system that we have explained previously, and then we test the results here from the pH, temperature, and turbidity. It can be seen that the prediction value is 5.33, for example, 26.9 and 20.79, and then there are also the real values, and then we compare both of the values. Here we can see the accuracy is around 99%, 99%, and 93%. We here use the average of the three accuracy values, and we get 97.67%. So before we reach the conclusion, some discussions are made. Before we created this research, we have a benchmark research, which is Kennedy from our reference number 10. In Kennedy, the accuracy was 57.8, which is quite low. If it is lower than this is actually a similar result to random prediction, and ours is 97.67, which is higher. The larger amount of dataset can be the reason. In Kennedy, they used around 4,000 datasets, and we use larger, around 9,000 datasets. So I think that is the cause of the higher accuracy. The low accuracy of Kennedy can come from overfitting. So Kennedy's model gave a high accuracy, but when it was tested, it gave low accuracy. That is one of the symptoms of overfitting. So if the problem is overfitting, besides adding the amount of dataset, other things can be done. For example, cross-validation method, or early stop method, or regularization. So lastly, we want to conclude our research and monitoring and prediction system of water quality pollution using artificial neural networks for freshwater fish cultivation reservoirs has been successfully built. The implementation of this research is limited to a laboratory scale test environment, so we didn't use it in a real pond. And the accuracy of the training parameters are 99%, and the results, the real results in the real environment, but in laboratory scale is 97.67%.
Great, thank you so much. Are there any questions? Okay, actually, there's no questions. Thank you so much for your presentation. Very interesting talks.
Thank you.
We will swiftly move to the next speaker. The next speaker is Zachariah Pabi Gariba. Are you there?
Yes, I am.
Brilliant. Good to see you. And the presentation of your talk is towards an advanced integrated security framework for cloud computing. Welcome, and please go ahead. You can start your presentation. You have 15 minutes.
Thank you. The title of this presentation is Towards an Advanced Integrated Security Framework. It's a joint work between Professor John Andrew Vanapo and myself. My name is Zachariah. Now, cloud computing has become a technological change, enabling SMEs to have access to ICT at lower cost. And we do know that the services provided by cloud computing are normally located at remote locations. Therefore, security becomes a critical issue because research have indicated that there have been serious and several cloud security failures. Available literature to us demonstrate that the current cloud security frameworks often are unable to detect attacks to cloud computing. And so in this research, we developed a framework, and we call it X framework. It employed the strength of popular cloud security framework that we considered during this work. And the framework, this X framework integrates the popular cloud security framework strength with autonomy computing, cloud forensing, and visualization. This enables the framework developed, the X, to detect threats, isolate threats, and also does investigation of security threats. Cloud computing transforms SMEs' choice of using ICT. However, there are certain security challenges that come with cloud computing. One we considered is malicious inside attack. Because cloud, normally there is an administrator who has access to management of the virtual networks. So sometimes there is possibility of an insider within the cloud who, after getting access, does certain threats and attacks to the cloud. In this work, we developed a research question, and our research question states, what are the strengths and weaknesses of prominent cloud security framework for preventing attacks to virtual machines, cloud transactions, and stored cloud data? And so we have to develop an objective to enable us to handle this research question. And our objective is integrating respective strength of the prominent cloud security frameworks that we considered, to synthesize them to form a new framework, which is the X framework, to prevent attacks to virtual machine, cloud transaction, and stored data. Our research is based on Sandal's research area. And in this research, we considered cloud security frameworks, and we divided it into two: those relating to the actual cloud and those related to other features that we adopted into the cloud. Those relating to the cloud security, we sampled and then we tallied certain properties, security properties of those. And the top, those with the highest number of properties, 5 were took. That were used to form our new framework. We also considered the Cloud Security Alliance's documentation on the current documents for cloud threats and vulnerabilities. In that documentation, there is Notorious 9, which was defined in 2013, giving 9 threats and vulnerability to clouds. And 5 years later, Treacherous 12, which is 12 threats to cloud security, were also formulated. And in this we tallied the 5 frameworks, the top 5 frameworks. The graph indicates the tally that were considered. From the bottom, you can see that there's a graph with 11. That means 11 properties. That framework handles 11 security properties. The 10 handles 10 security properties. The 8 similar, and then the 7 being the security properties that it provides. Now, in literature, we considered forensic practices for conducting cloud investigation. I mean, the security threat and attacks investigation. We also considered autonomic computing to create intelligent system for self-management. And we considered virtual system to allow the user to run a software from various vendors on essentially any hardware. The diagram for our framework, which we call the X, is shown. The framework has the general CIE trend components. We have the confidentiality, integrity, non-repudiation, and then security authority and the security management aspect. Then the second aspect is the which we call advanced system component. We involve the autonomic aspect and then the forensic aspect. Now let's look at a scenario. In this framework, if a cloud user accesses the cloud using a laptop, and in the course of accessing, the user will normally be granted with privileges and then all the necessary credentials that you need to access. However, in the course of using the cloud, after being granted the access, the activities of the user is being monitored by the autonomic computer. And if there's any threat or any issue as a result of being given access already, then the autonomic computer will initiate forensic investigation. And the outcome of forensic investigation may determine whether the cloud user should be terminated, because the cloud user may be seen as a threat or be allowed to control. So this X framework looks at security of the cloud system after access has been given to a cloud user. I mean, after the privilege, the credential has been granted, the activities that occurs, because we need to monitor inside attacks. Now, formal method has been identified as one of the means for addressing inconsistency and ambiguity issues during requirement elicitation. And so for this framework, we considered C specification for a cloud-based operation to formalize certain aspects of it, because we need to improve and determine the inconsistencies and ambiguity within the framework. We use the C and there's established strategy. So we define types to be the keys and then the data. Now the file system for our cloud system has been defined here by the schema. I mean, the Z uses schemas. So there is a relationship. We define a content to be a partial function between keys and data, because the types that we define includes keys and data. And an operation to delete an entry, we must give a key, being the second. I mean, I'm referring to the second schema here. If we want to delete an entry to the cloud, I mean, certain aspect of data, we must have a key. And that key normally, there's association between keys and data. When that key is pressed, certain aspect must be deleted. The total operation that has to be considered for the complete deletion of a data within a cloud system has been given by the third schema. And in this third schema, we define a reporting portion aspect. In other words, if the key is pressed and the our filing system within the cloud is deleted, a report will be given, meaning record deleted. And if different key is pressed, I mean, which is not part of the content, there will be a report which indicates that the key is not found. In other words, the key for deleting it is not what has been pressed. In conclusion, we develop an X framework. I mean, this framework is built upon the strength of prominent security frameworks together with virtual machines to solve and address issues relating to virtual machine and install data. And that this framework that we develop, it is based on the strength of 5 frameworks that exist already, together with autonomy computing and then forensing. And then we demonstrate a certain aspect of the framework that can be formalized. Thank you, and questions are welcome.
Thank you so much. Questions are open. Zachariah, looks like nobody has questions for you. Thank you so much for your presentation. That was interesting.
Thank you.
Thank you.
Thank you. Thank you.
Is the next speaker available? Sajal Bhatia.
Yeah, myself Sudesh here. I would be talking on behalf of Sajal, since Sajal couldn't able to make it to the presentation.
Okay, Satish, thank you so much. The title of your presentation is Comparative Analysis of Cloud Computing Security Frameworks for Financial Sector. Sajal, please go. Satish, please go ahead.
Yeah, sure. Okay, I hope you could able to see my screen.
Yes, we are. Go ahead.
Yeah, thank you. Thank you everyone for joining up for the presentation on this, and thanks for ICICT for shortlisting our paper. So basically, we are going to present about the comparative analysis of computing security framework for the financial sector. So objective of this security framework is to, where the security is a big challenge in the cloud system due to its nature of outsourcing computing, mainly the confidentiality, integrity, and the authentication. Where the cloud security framework is the core functionality that helps in secure the entire environment of the organization and of the IT infrastructure. So unless a robust security feature as user-centric the policy are implemented, the cloud security would be vulnerable to different attacks and susceptible to the users as well. So the main objective of this paper is to research on a cloud security framework were being used in the financial sectors. So where we picked up 4 cloud computing security framework, and we did a detailed research based on today's world in the financial sector. And we come up with where the 4 security framework, which is more secure and reliable for the financial sector, which meet all the security standards and guidelines. So these are the 4 security frameworks which we took. So one is a cloud security reference model. The next comes with the novel open security reference model and the Temenos, and which comes with the Sherwood business applied, which is known as SAPSA. So when we go into the cloud security reference model, so basically this reference framework is used by CSA, which is called as the Cloud Security Alliance. And this framework, its main objective is which helps environment with security control with the client and server. So which this framework can ensure not only the security of the client and server, but it also ensures the integrity of the cloud service as well. So the security framework, one on the main option is which is integrity of the cloud service. So the data integrity in the cloud system means preserving information integrity. The data should not be lost or modified by unauthorized users. Like data integrity is the main base of providing cloud computing service like SaaS, PaaS, or as. And in this cloud security reference model, there's a 5 critical pillars. One is identify, protect, detect, and respond, and the next one is the cover. So the purpose of this is to identify, which is identify the risk and performance and risk assessment wherever it's necessary. And in terms of protect, to make sure that the organization is protected, risk-free, and able to sustain during any kind of attack. And next is detect, by identifying the security related event occur in an organization. So it should detect based on the framework what we designed. And next one is respond, like how the incident response team is aligned. So similarly, like there should be a mechanism which would be set in the security framework, which would respond to our any kind of attack happen to our security frameworks. And next one comes with the novel open security framework. So the main objective of this framework is to ensure an end-to-end security in cloud computing. So novel open security framework is based on purely organization-based specific security solution that can be changed dynamically. And as we can see, like the novel open security framework is mainly based on like physical security and the network perimeter security, which will says like virtual image, identify access management, data security, as well as the client level security. So these are the security domains which is in the framework, which assess the security aspects of various operating entity and provide the backbone for the secured environment. So, and the other thing to add up to novel is which is not been practically implemented in any real world environment. So still this novel open security remains in paper. So probably this would be the one of most secure security framework which we found, but since it's not in real world experience, so we couldn't able to make this as one of our prior security framework. And next comes the Terminus Enterprise Framework architecture, which is mostly it's been designed from Terminus, which is normally known as T24 Enterprises Vision in the market. So TEFA is based on the standard software, which is provide solution for major banking hurdles. So the purpose of T4 as an organization can mold the product based on its requirement. The TEFA is adaptable to all core banking requirement. It also does not require any changing to the existing core banking system, and which can be deployed by using a middleware which will be provided by the Terminus as well. So overall, Terminus allows the user to choose required or a convenient platform framework to integrate with T24 architecture. The platform framework enables the user to integrate with any platform partner or the product. So basically, this would act as an overall security, overall package for a banking industry or any financial industry to the matter. But it will not act as a security framework, but it will come with entire package of like security framework along with your all integration process as well. So next comes the Sherwood Applied Business Architecture, so which is normally called as SABSA. So here SABSA is mostly described as a conceptual security architecture, since it defines the guide and organization to bring up the framework based on the requirement and need from the very basic. So the basic purpose of Sherwood is answering the 5 basic questions of any financial industries, like what, who, why, where, and when. And this is like this framework answers in such a way like what type of clouds are deployed in being used, and who will be using the infrastructure, and why you answer the question, the core purpose of the project, and where do we implement the use of control down matrix, and how the security standards and guidelines are framed in this project. So SABSA consists of like 6 layers, including like security service management architecture. So which comes with contextual, conceptual, logic, physical component, as well as the security service management. So each component will have answering all these 5 questions for a financial industry, why this conceptual method is being used, or what is the purpose of this project, or why the security framework has been implemented in this project. So it asks all the basic questions for any financial industries. So this would give more towards from each segment from starting till end of the end of the session of the project, it keep answering all the 5 major questions for the financial industries. And so when we compare our parameters like into cloud security framework, we used like 4 different methods. One is deployment model structures, and which is nothing but private cloud or private or public or in a hybrid clouds, and which we compare the service delivery model, how the service delivery model is being used, even if it's used IaaS or SaaS or PaaS or security service model. And the security mechanism, what we chosen is like how it's been audited, how the authentication is being done, how access management rights are being issued to every users or every person is being used across. And the guidelines and security standards is nothing but like what are the basic guidelines which has been taking care, like NIST or COVID or ITIL, and how this guidelines has been implemented in each security frameworks. And as a conclusion, like as we talk across TEFA is purely based on a software solution product that can be integrated into any security framework. But while we look into as a solid security framework, TEFA will not fix into any every business model, as this will provide as like a software solution, not purely as a security framework, but it has an integrated method of security framework towards this this framework. Similarly, the novel open security framework, as I stated earlier, like this framework doesn't as not having any real-time experience or in a real-world environment experience, so we're not able to try with a paper-based based on security frameworks. And next thing, while we compare like CSA as well as SAPSA, so which we can say, let's say cloud security reference model has been used in a quite while in the market, and which is widely used across in all the market. And we prefer going with SAPSA as one of the best option, because it gives additional features like a security mechanism where it questions every steps which has been taken by an organization or any IT projects, like who, what, why, and where. So we would prefer going with either cloud security reference model, or a SAPSA would be the best ideal option to choose with for going up for a security framework. And in future work, we would like to research how the security frameworks works in a real-time environment for any industries collective and collect the feedback from the case studies. So as I said earlier, the novel has not been implemented in any system or in any IT environment area. So we would prefer saying like we would try doing that novel open in future, and then see like if what would be the feedback from the industry. Then we could say like, okay, this can give a much better option, or which can be giving a much better option in the real-time world. So yeah, thank you. That's how my presentation is done. So if I could take up some questions if you have.
Sudesh, thank you so much. The field is open for questions. Sudesh, no questions. So thank you so much for your contribution.
Yeah, thank you. Thanks for the time.
Thank you. Okay, the next speaker is Mohammed Artan Abdi. Are you there?
Yes, I am there, sir.
Thank you so much. The title of your presentation is Event or Emergency Case Detection by Human Running. Mohammed,
Yes, sure.
Please go ahead with your presentation.
Okay, thank you. I think you can see my slides, right?
Yes, we can.
Okay, thank you. Since we have the less time, I will talk about very quickly. First, I will talk about the introduction, what we do, and the methods that we use to do it, and the result we produce. Then I will talk about the conclusion of what this project is talking about, how we did and what was it. Let me talk about the introduction first. Event or emergency case detected by human result and by human action. It means we need to detect whether human is working or running. We need to make classification those two categories in only one achievement goal. And this is what I'm talking about. Our goal is to recognize, just like this now, this female, she's running just like a sport. And this man is running, maybe he's something at risk, but he's trying to escape from the police. So we need to catch this running to separate other actions. This is a running, this is not a walking. So our system is making classification from these two actions. And as I talking about this paragraph, sport is the fundamental necessary. So we need to help our social to make a sport more integration, more beautiful than this way. So we need to catch the upcoming risks to make them security and safe. So if I'm going to continue in person in human, we can guess like what this action is, or where is it starting, or what he's doing. See running, see taking something at risk. But after technology come to our routine life, so important. Everywhere in the world today is technology. So there is a question come to a researcher's mind. Can machine can recognize just like a human brain? We think so. So this research we are talking about, if the machine can recognize such like human brain, so we don't need human brain. So if I talk about a little brief of machine learning, as we know, machine learning was started in 1950s, early 1950s. I would like to acknowledge and also Samuel, and the one who's produced the phase of machine learning after 2 years, 1952. After that moment, it started a binary system by a simple algorithm. Day by day, the algorithm was going up. Then it was very growing up than normal researches or similar researches. That's why it became machine learning. This is the area we discovered. In those articles, we saw they are similar to our work. So that's why I selected the top 4 top 4 researches that's similar to our work. They are near. They did what we did same, but we are different. All of them, they are different. We are different from other, but we are a same family. We can say we are near same family. Talking about these are attribute tools in engineering or research. Making something research, we definitely need a data set. Without data set, we can't make any research. So that's why I will talk about the data set. An algorithm, which one is appropriate to our system. There's many different algorithms, and the model after that selecting algorithm. Our data set, we collecting 2 of images from the environmental. Our first experimental, we testing 1,000 image from walking and 1,000 image from running. We collecting from the environmental as about approximately 70% of the data set we collected from the internet, freely website, and 30% we extracting from the videos. That videos was collecting inside the environmental. We just make a camera, we just collecting, we just record the video, and then we extracting that videos into the frames to make a data set. So our first experimental, we tested 1,000 image from walking, 1,000 image from running. And sorry, I would like to inform you another thing. Our dataset contains 2 different tags, singular image and plural image. Singular image is 1 person, 1 frame, but plural image or a group, we can say group image. Group image is a 1 person in different actions, or 1 person in 1 action but different angles. So we call them plural image. Individual or singular image is 1 person, 1 action, 1 time. I continue. This is our algorithm. As we know, artificial intelligence allows to computers to take their own decision. Machine learning is the child of artificial intelligence family. So we selecting machine learning, but we saw deep learning. Deep learning is the same function with machine learning, except it takes a large amount of data than the machine learning. It takes less time of training and the prediction. So means we selecting deep learning as our algorithm. So this is the model. We selecting model CNN, convolutional neural network, is a powerful model in deep learning, which image emphasizes various expertise and can be able to recognize from one other image. So that's why we selected. And also it's a feed-forward network and directing data from one input to output, only one linking. This is the hypothesis. I don't need to waste any more time. So as I talk about, our methodology is deep learning and convolutional neural network as a model. So let's continue. How we building our data set. Let's start first. We collecting data set from the environmental, as I talked about earlier. We make a frame and we editing as a carefully. We editing the way there was possible throughout to the system. We edit and then we prepare the frames with a carefully. Then we load the data to the system and changing the limitation because of we as I say first, our first experimental was 2000. So 1000 image can be 1000 pixel. One image can be less than 100 pixel. So we need a limitation pixel that all of the images must have. So we change the limitation, we change the capacity of the image. After that, our our fourth step that is more critical, the important main step is the training set. If our training set, if our training step is lost, means our program all lost. But if our training is win, so that is our criteria area. So then after we training, we come to the in testing, predicting and checking the quality of the result. After that, we produce the result. Our result, we plan the structure using a confusion metric stabilis. I will talk about later. Vertical, horizontal, ASICS chart as we use as our accuracy rate, and I will show you that is our work. And this project we building in Python with using a Kairos and TensorFlow libraries. We know these libraries are one of top 10 libraries in today. So they are a very useful tools and very commendable tools. And the technique, so I don't need to waste any more time. So the images, as I talk about, we have only one achievement. So let me talk about the technique we use. In our human thinking, we know the person, if he's starting the way his action is starting, so we can guess like this person is running, like from his nails, from his hand, from his legs, from his body, we can understand this person is trying to run. Just like same we did to the system. That is our hint. Our hint was before the person starting walking or running, what action is in that second is you do. If his action is running or is trying to use his hand, means this person is trying to run. So we can predict that this person is running. After that, the system is going to send this image to the running area. If it is running, the system will say, okay, this person is running. If he is not running, the system will say, okay, this is a problem. So we will take this image from the running to the walking side. This is the result we produced. We take a list of experimental results, many experimental results, and a series of images downloaded from the internet. We're preparing a careful so that they have the appearance only singular achievement for every single file. This is our experimental, the simulation of our experimental. And so you can see the number of epochs. We started from 10 epochs. I did not show, put it here, but I put it here, the summarization of number of e-boxes, number of returning e-boxes. So I started from 1,000 up to 3,000, but number of e-boxes was starting from 10 to 100, 100 to 1,000 up to we come to 3,000. And our total accuracy rate we get was nearly 87%. So we can say 87% was our accuracy rate. This is our horizontal vertical ICICT. As you can see, our accuracy rate and the testing rate was a little bit, it was starting from very low, but it was going up at it become nearly 89%. And this is the confusion metric is we get it. As I talked before, our confusion metric is not 100% successful, but it is 87% because of we will first when we making this experimental. Our first experimental result was 10 data set was very low. So after that, we come to the next stage, second experimental. The second experimental was a little bit greater than. Then we come to the third experimental. After we come to the experimental, we get an error. We get a gap. So that gap takes a lot of time to fix it. So we add more layers. We change the situation. We change the scope of the system. Then after that, we come to the fourth experimental result. So after that, after we become our fourth stage, our approximately percentage we get was 87. We say like, okay, 87 is not bad, but it's not 100%. So do we successful 87% if you have, or do we fail it? At least if we go back and check in the place we came from, 80% was the successful ratio. And this is the result we produce. If you can see, there is 4 images, walking, running, walking, running. This female, she's walking. So the program is described that she is walking. This man is running from, it's like in front. So there's no angle image, but he's running. So the program is recognized that he's running. And this man is walking while this man is running in the beach. So our first result was commendable because our first experimental we get the result, successful result, but we need to extend the data set. So that's why the number of e-boxes are increasing, the number of errors are increasing until we get 80%, 87% approximately successful. Thank you. And this, let me talk about the conclusion. Sorry. And this research, the ultimate is to classify an improvement and accuracy of classifying image file with the process of combining the action concerning the movement. There are exclusive of training and testing comparison with the image. The study was based on system with building in deep learning using more particular CNN. So what is our future work? We would like to extend this project. We would like to add other actions such like someone is fighting another person. So we need to add who's one is starting the push, who's one starting the problem. So we need to help with the criminal investigations to help with which one is starting the project. And our upcoming result, our future work, we would like to add a market, heat mark, like group of people, like a market for 5 persons in one place. Which one is running? We need to mark this one is running, this one is making something issue. So that is our future work if it is possible. And this is our team. My name is Mohammed Artan and I'm Somali. I came from East Africa. And this is Metin Turan, he's a professor in Istanbul Ticaret University. Thank you. If you have any question, feel free, please.
Thank you so much, Mohammed Abdi. Any questions for Mohammed? Okay, no questions for you. Thank you so much for your contribution.
Thank you. Welcome.
Okay, is the next speaker here, Bajila Aegis. Is Bajila Aegis here?
Yes, I'm here.
Oh, fantastic. Welcome, and your presentation, well, you're doing a review of contract identity extraction.
Yes.
Please go ahead.
Let me share my screen.
I can see your screen. Thank you.
Oh, thank you. Very good evening to all. Myself, Bajila Ejas. I'm from Qatar, and I'm a student of Qatar University. And today our topic is a review on contract element extraction. This is a part of a research on NPRP project, which is funded by the QNRF, and the project is Supply Ledger project. And let us move on to the introduction. One minute, excuse me, give me 1 minute. Okay, sorry for the interruption. Let us move on to this introduction part. We know that contract, what is a contract? A contract is a legal document between two or more parties that defines the rights and the rules and regulations that the participants involved in the contracts. So contracts are very crucial and they must be handled very carefully in order to avoid the loopholes and other legal disputes. So in the case of supply chain is one of the biggest domain that is handling lots and lots of contracts at a time. So the supply chain management include the management of the contract also. So in the case of supply chain also, contracts are very crucial. So for handling or managing a contract, usually what we have to do is drafting, reviewing, and managing the contracts manually. It will take lots and lots of time. And also it's very costly and it is prone to error and always go to the legal disputes at last. So in this digital era, it is a big chance to automate the contract management. So it will be a bigger hike for the supply chain management also if we can automate the contract in the supply chain. For example, if we can transfer the contract into a smart contract so that we can apply it in the blockchain, which opens a door for exploiting the blockchains in improving many of the issues faced by today's supply chain management. So our proposed methodology is the automation of the supply chain contract element extraction. This is a basic part of the contract management, that is the entity extraction from the contract using deep learning methods. And the challenge, one of the big challenge in this area is the data set creation. So, and the next step we are thinking of is that the extraction of the best contracts. Based on these extractions, we can propose the best contract template from these and then convert that contract into the smart contract. This is the architecture. Actually, we are in the initial step, that is in the data set creation. And the basic architecture now is that the first step is the data set creation, which include the collection of the supply chain contracts, then identify the main elements from that contract, then annotate that contracts based on these identified entities. This is the first part, and we are in this area now. And then the next step is applying deep learning methods for entity extraction from these annotated contracts. Then the final step here is that the proposal of the efficient smart contracts so that we can enter into the blockchain. So before explaining too much on this architecture, let us first have an introduction on what is this entity recognition. Artificial intelligence, we know that in every part of our life now, artificial intelligence is having a big role. In AI, there are many methods for entity recognition and entity extraction. One of from the entity extraction from the document, from the text, is done by the named entity recognition methods. And this is a part of natural language processing. So the extracted entities or identified entities are called the named entities. So generally, the named entity extraction recognition methods identify the named entities like persons, organizations, locations, time and date, etc. There are many pre-trained models for NER currently available. For example, Stanford NER, OpenNLP, Spacey, etc. This here, this is an example from Spacey, identifying these entities from this document. So next, what is the problem when we are using this pre-trained NER in contracts? Let us move on to that. First problem is that the contracts are purely domain specific, and these NERs, already pre-trained NERs, are actually trained for extracting the general entities like person, locations, etc. So for domain specific entity extraction or recognition, we need the model to be trained with the domain specific entities. There are domain specific named entity recognition methods for different domains. Like for example, we have many NER methods for medical area. But here in this area, in the area of the contracts, there are not much more researches going on. Only few are there. And due to the problem of security, most of them, the data sets are not publicly available. So because of that, the main challenge comes here is that the shortage of the annotated data set. We need annotated data set in order to perform NER, so that the data sets can be used for training using any machine learning methods or deep learning methods. In fact, for deep learning method, we need a huge data set. So there is a big shortage of annotated data set in this area. And if we are using these pre-trained NERs for this contract entity extraction? The problem is that the pre-trained NER, so for example, the pre-trained NER can extract or identify the date from the document. But in the case of a contract, we have different types of date, like starting date, termination date, effective date, etc. So we have to identify that specific date in which part, or which it represents which date, whether it is starting date or effective date, etc. So this is not possible when we are using the normal pre-trained NER. So in the case of contracts, we need a domain specifically trained on these contracts NER method. So let us move on to the first part of our architecture, that is a dataset creation. So our aim here is to manually create an annotated dataset. So that will take time. We are currently working on it, and our aim is to make it publicly available for the research work, so that it can be used by many people. And then we can use these deep learning methods for implementing NER. This is the first part, that is dataset creation part, that we are aiming to do. So let us move on to some literature reviews happening in this area using this machine learning and deep learning methods. First one is that by Ilyas Chalkris and his collaborators. Is one of the researchers currently working on in this area, and he has 3 papers on this particular area only, particular element extraction from contracts. And in his research, he used a data set of 3,500 contracts, which are manually annotated. But it is publicly available also, but it is only in the encoded format for security reason. The methods he used are the rule-based methods, logistic regressions, SVMs, and then he applied a hybrid method of manual and machine learning approaches. So here the best result comes from the hybrid method. Then also he used the machine learning method, and the final result is manually controlled by the rule-based method. That's why for hybrid method he got a big result. So, and here is his second paper with the same data set, but implemented with deep learning method, that is bidirectional LSTM. And he experimented with a different logistic regression and CRF and LSTM LR as final layers of this bi-LSTM. And from all the results of both papers, bi-LSTM is performing better than the previous method. These are the results obtained. You can see that the hybrid method is having a higher value, but it is having a post rule-based updation on the result. And another literature on this is his third experiment. Here, instead of using machine learning, normal statistical machine learning methods and this bi-LSTMs, he used neural encoders like stacked bi-LSTMs, dilated CNNs, and stacked transformers. And here he uses single multi-class classifiers for all the entities. But in previous cases, he used one classifier, one binary classifier for one entity. Here also the results shows that bi-LSTM is outperforming the other methods. This is another study on this by Sandeep Joshi and his collaborators. Here the entity is the location of parties in the contract. So the data set he created is by taking the contracts from the Law Insider website, and he manually annotated. And the methods this team used are the naive-based and the decision tree method. And another one is by Ruka Funaki and her collaborators. And the entity here is the right and obligations of the parties. We have different entities from the contract. So for the specific function, we have to identify which entities are to be retrieved. Here they are using right and obligations of the party for their research, and the data set they created is 40 Japanese and 25 English contracts, and they manually annotated this data set. And they also used a bi-LSTM, and they got a better result for bi-LSTM. This is the result. And the current work we are doing is on data set, as I said. We have got a small data set which is publicly available in recently by the Atticus project, which contain 200 contracts and 40 categories. So we are working on by making this as a model, and we are creating more data set, more documents and annotated by this based on these categories. So from these 40 categories, that is the 40 labels we have to annotate. We are deciding which one is to be wanted in our side. So the contracts are taken from US Securities and Exchange Commission, SEC, that is publicly available. That is a pure contract, and we need to annotate it. These annotated data sets are in short are not available much in this area. Now our idea is after annotating all these data contracts, we will first use bi-LSTM to implement this NER. Then based on that, we will continue our research. And the conclusion part, the main aim here is the contract entity extraction. The difficulty or challenge in this area is that we cannot use NER directly because of the lack of the annotated data set, and we cannot use pre-trained NER directly because of this domain specific issue. And mostly in the case of this legal area, people are normally lawyers need this and a contract review. All these are done till now manually. Only little works are done in the AI area only. So that is very time consuming and error prone. And we have done various researches, various literature review in this area, and we have here we discussed various researches with the results. And now our focus is on building the annotated dataset in this supply chain management domain and make it available for researchers. And after that, our aim is to automate the process. These are the references.
Go ahead.
Thank you.
Great, thank you, Bajila. Any questions? Bajila, no questions. Thank you so much for your contribution. Very interesting talk.
Thank you for ICICT for this opportunity. Thank you very much.
And this concludes the session. Thank you, everybody.
Sorry, just quickly, if everyone can turn on their camera for a quick screenshot. Yeah, I'd like to thank everyone for joining us. I know we ran over time. Sorry, yeah. Yeah, if is that everyone with the cameras on? That's perfect. Yeah. Got that. Just want to say thank you to our chair for taking the session.
Thank you so much, everyone.
Yeah, thank you all for coming today. Have a safe trip to everyone. Please stay safe out there. Thank you.
Yeah, thank you.
Thank you.
Everyone.
All right, bye.
Thank you.